Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, and welcome back to this end of term coverage for term 3 mathematics for grade 11 advanced. And this is the second part, and in this part we will discuss the unit of polar coordinates, and I hope it will be easy for you. It's quite an easy topic. There's not much to understand and learn. And as always, the way the video is going to be is that the first part will be the explanation of the topic itself, its concepts, and if there is some equations, and then we will move into solving some questions based on the material provided by Mr. Ahmed al-Baghdadi. So I hope you enjoy the video and find it helpful for you. And some good news, this video is inshallah not going to be as long as the previous video on vectors, because we will use a lot of the knowledge that we obtained from the last video into this video. Not a lot of it, but some of it, the basic things. So it's not going to be as long. So the topic is polar coordinates, and I hope I write coordinates correctly. I'm not sure of the spelling. Polar coordinates. I'm sure it's not correct, but let's consider it for now. And the main topics that we'll explain will be, first of all, the representation of the polar coordinates, so of polar coordinates, and second of all, converting from polar coordinates all the way to rectangular, and then third thing, converting rectangular into polar. Let's start by representing the polar coordinates, and how is it done. Now, if we consider the normal coordinate plane or the Cartesian system, we learned that we represent it in an ordered pair which showcases x and y positions, right? So this is for the normal Cartesian system. If we move to polar, it's going to be a little bit different. It's going to be r and theta. So what does this mean exactly? Now, the Cartesian system does not look like the polar system, right? The Cartesian looks something like this, right? Where you have the x and y axis. But in the polar, we have the axis, the polar axis itself, and then we have some circles with increasing radii, and so on and so on. So for example, this is, let me change the color. So this is 1, and this is 2, and so on. And this is, of course, r. So the way we are going to represent, for example, this kind of line here to this point, and let's say the angle is, for example, 45, and it's going to be, of course, 2 units long. This is going to be 2 and 45. So this is how we represent polar coordinates. Now, of course, because the polar coordinates offer us 360 degrees, we can have more than one representation to a certain point. So let's draw an example here again. So this is the polar axis, and we draw some circles. Not very good looking ones, but I hope they do the job. So we have 1, for example, here, and we have 2. And let's draw a point. So let's draw a point, for example, here at an angle of 60 degrees. How can we represent it? Now, there is the first way, which is going to be its radius, and again the radius is 2, and the angle is 60, so 2 and 60. and this is the first representation. But we can also represent it in another way. If we draw, for example, another point that is here, that is directly opposite to this one, and also add a radius length 2, but in kind of a different angle, right? This angle is 60 plus 180, of course, right? So 60 plus 180 is 240. So this is 240. So let's write it here, 240. But in this case, we will not write 2, but we'll write negative 2. Because what the negative does is just moves this part here into the other side. It moves this to the other side. This is what the negative does. So the angle is different and the sign is also different. This is another representation of the same point. There is another representation, but this time instead of changing the sign of the R itself, we will change the sign of the angle. So instead of going counterclockwise, we will go clockwise. We will go clockwise like this. So let's do it. We will still write 2, but instead of writing 60, we will write this. What is this exactly? It's 360 minus 60, right? And what is it equal to? It's equal to 300. But will it be positive 300 or negative 300? It would be negative 300 because we are going clockwise. So this is also another representation of this point. So there is always more than one way to represent any point in the polar coordinate system. So I actually checked the spelling and it's polar coordinate like this. Now everything is great. So we finished in representing polar coordinates in different ways, and of course when we solve questions it would be much clearer for you. Now let's talk about converting polar coordinates to rectangular coordinates. And polar coordinates are what we just discussed, having r and theta, but rectangular coordinates are just x and y. So we will move from r and theta all the way to x and y. In order to do that, I would like to remind you that if we had, for example, this system here, and we had a vector that goes in this direction and it has a length r and it makes an angle theta with the positive x-axis in this case. So what will the x projection be and the y projection be? So we know that the x projection is going to be r cosine theta and the y projection is r sine theta. And this is exactly how we convert from polar to rectangular. So let's take some example. We have 4 and 30, for example, and we have to convert it into some form where we have x and y. Let's visualize it, and then at some point it will become spontaneous for you. So 4 and 30, let's draw again the polar axis, and then draw some circles here, and this first part is going to be 2 and second part is 4. So if we will draw this, it will look something like this. It will go all the way to 2. Here is the point, and the angle is going to be 30. So in order to find x, we will do 4 cosine 30. This is for the x, and for the y, we will do 4 sine 30. It's that easy. So let's do it. I will move all the way here, and let's write the result. So 4 cosine 30 is just 2 root 3, and then 4 sine 30 is just 2. And this is the rectangular form. And this is just it. Now let's do it the other way. Let's convert from rectangular to polar. And I think this is more interesting, but it's the same idea. So if we have x, we will just plug in its place our cosine theta, and if we have y, we will plug our sine theta. And we have some examples, and we will take them in the second part of this video. So let's solve some questions to practice and understand the ideas more. So this question asks us to find other representations for a point called T that has these polar coordinates 4 and 135. So what are other valid representations if theta is between negative 360 and 360? Because if it was not for these boundaries that we put, then there will be infinitely many solutions to this. So let's try to find other polar coordinates. And let's draw, I think, a good polar system here. So we'll start with the polar axis, and we have the first circle and the second circle, and each one has an increment of 2. This is 2 and this is 4. Let's draw this 4 and 135. I think it's obvious that this is pi over 2 or 90 degrees. So point T is going to be somewhere here. And this is exactly 45 degrees from this point, because we have 135 and we reached 90, and we need another 45 to reach 135. Therefore, we know it's exactly 45 from the 90-degree point, and we can draw a line to make it more obvious. So let's find some points that are also with the same representation and same value, but look a little bit different. So the first idea is not using positive angles, rather using negative angles. So instead of going like this, we will go like this. So we will keep the 4 as it is, but instead of positive 135, we will go just like this. And to get it, we know that if we extend this, we will go 180 degrees like this, and then we will go another 45 degrees here. And the reason this is 45 is this is also 45 as mentioned before. Therefore, we will go for 180 plus 45 or 225. But it's not going to be positive, it's going to be exactly negative. The second method into getting a correct result is, instead of using a positive value here, we'll use a negative value, a negative 4 here. So let's do it. We have negative 4 here. And to visualize this negative 4, there are two ways. The first way is we draw a negative 4 from this side. So we draw something like this, where this point is in fact at negative 4. And then we go clockwise by 45 degrees. So negative 4, and then we go by 45 degrees clockwise. So it's going to be negative. And we can get this result by another way. So we can go to 4 and then go to negative 45 degrees, just like this. This is negative 45 degrees. We will have a point here. And this is 4 and negative 45. And to actually get the point T, we will have to change the sign of the 4, so we can move all the way from this point to this point. And this is a second answer for it. In this way, we found two different representations of the same point. And of course, there are also other representations that we can find if we continue doing the question. I think we can reach up to 4 different representations. I will leave that on you. If you have a nice result and you're ready to share it, then please send it to my email and I will be happy to discuss them with you. And this is another question with the same idea. Let's find different polar representations of this point. I will find 2 and then we'll move to the next questions. And if you want to find other ones also, this will be great. This will show that you understand the topic quite well. So let's draw again a polar system here with an increment of, let's say 1, 3, and then another one here. Okay, 3, and then 5. So it's not very symmetric, but let it be used to represent this situation here. So we have 5 and 240. So how do we reach to 240? It will be something like this. So we know that this part is pi over 2 or 90. And then we know this part is 180 degrees, which is pi. So this is pi equal to 180 degrees. And then to actually reach 240, we will have to add 60 to this. So we'll go by 60 degrees here to reach this point. Let me change the color. So this is actually the point that we want. Okay, so let's get different representations. So the representation that was used was basically like this. So my first thought is to do something like this. So the first thing is 1 is going to be, again, 5. The sign of the magnitude will not change. However, the sign of the angle will change. So instead of doing 240, we'll do 360 minus 240, which is 120. So we went by 120 in this direction. And of course, going clockwise means we will have to put a negative sign. And the second idea is changing the sign of r itself. So instead of putting 5, we will put negative 5. And to actually get negative 5, we will go all the way here, where we have a magnitude of 5 and some angle. What this angle going to be? This is exactly vertical to this angle. We said that this angle is 60 degrees. So this is also going to be 60 degrees. So we can put 60 degrees here. And what this negative sign did is move this all the way here. And then we can also find other ones, but I will leave that on you. Now this is probably the easiest concept out there. I will just rewrite this into degrees, or you can either move your calculator into radian mode if you want to solve it like this, but I will move it to degrees also to talk about the conversion itself again. So we have 4 and 30 degrees. And why is it 30? We will do the unit conversion from radian to degrees. It will be radian, of course, times 180 divided by pi. So let's verify it here. Pi over 6 multiplied by 180 over pi. What happens is pi cancels out, and then we have 180 divided by 6, which is equal to 30. And this is how we convert it. And now, since we have the, of course, polar form here, we can convert it to rectangular. And in rectangular, we are concerned with the x and y. We know the formula for x is r cosine the angle theta, and y is r sine theta. Let's substitute numbers. For x, it's going to be 4 cosine 30, which is equal to 2 root 3. And then here we will have 4 sine 30, which is equal to 2. So the final answer is going to be 2 root 3 and 2. This is exactly the same idea. So x is r cosine theta and y is r sine theta. So let's just plug in the numbers. We will have negative 2 cosine 135, and then here we will have negative 2 sine 135, and here, if I'm not mistaken, it will be 1 times root 2. This is the answer, so this is going to be root 2, and this is going to be negative root 2. So the answer is root 2, negative root 2, and of course you can do it using the calculator. This question has the same idea. So we have negative 6 and not positive, but negative 120. And again, x is equal to r cosine theta and y is equal to r sine theta. Let's plug in the numbers. We will have negative 6 times cosine negative 120, and this is going to be negative 3. And here, same idea. Let's plug in the numbers. And the answer is going to be 3 root 3. And this is our final answer. Now, this is probably the nicest part. And to actually solve this, we will have to change the x and y's into the suitable polar quantities. So let me remind you that x is equal to r cosine theta and y is equal to r sine theta. So let's do it to this equation right here. So in place of x, of course, we will put r cosine theta minus 4 all squared plus, instead of y, we will put r sine theta and all is also squared, and this is equal to 16. And now we just extend the formula itself. Now this easily becomes r squared times sine squared theta, as this power distributes. And then this is a difference of squares. And let me remind you, if we have a minus b all squared, it's equal to a squared minus 2ab plus b squared. So let's do it here. What will we have? We will have a squared, so r squared cosine squared theta. It's just exactly the same as r cosine theta all squared, right? So we'll just distribute the powers and we'll get r squared cosine squared theta minus 2 times a times b, so 2 times 4 times r cosine theta plus b squared, so negative 4 squared, that's 16. And what I can see immediately from here is we can cancel out the 16s. We will minus 16s from both sides, minus 16, minus 16, and we can cancel them out. So let's rewrite. And let's have a look at this. This really looks nice because what we have sine squared and we have cosine squared, and we know what we will get from this. We will get 1. Of course, I forgot to include here that all of this is equal to 0. So to isolate the sine squared and the cosine squared, what I will do is I will move this 8r cosine to the other side. So I will get this equation, we'll get r squared cosine squared theta plus r squared sine squared theta is equal to 8r cosine theta. All right, and from this I will continue here. The thing is I'm going to factor out the r squared. So if I take r squared outside of this, I will get cosine squared theta plus sine squared theta, and all of this is again equal to 8r cosine theta. The beautiful thing about this thing is equal to 1. So I can write it like this. R squared is equal to 8 cosine 8r cosine theta. Therefore, we can divide in the final step by r. So this r cancels out and this power cancels. Therefore, we have r is equal to 8 cosine theta. And this is the final form. To revise, the first step was that I distinguished what x means and y means, and based on that I replaced the x with r cosine theta and the y with r sine theta. And then what I did is I broke this power here, so using this theorem here. And after I broke this power and distributed, of course, the power of 2, I moved the middle term, 8r cosine theta, to the other side to have this amazing identity with cosine squared and sine squared. After I did that and I left them on one side, I factored out the r, this r and this r. I factored them out to have it here. And then I had cosine squared theta plus sine squared theta, and this is of course equal to 1. I moved here, I have an easy equation that gives me the final result. So another question, let's again rewrite x and y. We know x is r sine theta and we know y is r sine theta, and based on this let's substitute. So we'll have r sine theta in place of y. Let me change the color. So this is y is equal to x squared, and here I will put r cosine theta, and all of this is of course squared. Let me break out this square root to simplify. I will have r squared cosine squared theta is equal to r sine theta, and I want only one r. I don't want an r squared. So what do I do regarding this? I will divide both by r. This r will cancel out, and this power is going to cancel. Therefore, we will have sine theta is equal to r cosine squared theta. And then this expression here, I want r to be on one side while all other variables to be on the other side. So I'll rewrite it here. So sine theta is equal to r cosine squared theta, and I will divide both sides by cosine squared theta. And I will get r is equal to sine theta over cosine squared theta. And this is a final answer, but of course it can be simplified further. How do we simplify it? We can break this to two different fractions. We have sine theta over cosine theta times 1 over cosine theta, right? And sine over cosine is easily tan, right? So this is tan theta. And then 1 over cosine is just secant theta. This is equal to r. So this is the final polar form. And to solve this question, it's not very different. Let's remind that x is equal to r cosine theta and y is equal to r sine theta. And what we will do is just substitute these values. So instead of x squared, I will put r cosine theta all squared plus. Instead of y, I will put r sine theta and of course minus 3 all squared, and this is equal to 9. The following step is just simple algebraic simplification. So r cosine theta all squared is just r squared cosine squared theta, and then plus, for this part here, I'll just remind that if we had a minus b all squared, that's equal to a squared minus 2ab plus b squared. So let's do this simplification. We will have r sine theta all squared, which is the same as r squared sine squared theta minus 2 times r sine theta times 3, which is b, plus negative 3 squared, and this is equal to 9. Let's continue the simplification. We can rewrite it r squared cosine squared theta plus r squared sine squared theta minus 6r sine theta plus, so plus 9 is equal to 9. And from here, we can cancel the 9's if we subtract 9 from both sides. And then we can see this beautiful identity again. Cosine squared plus sine squared, and we know its result, 1. Therefore, we want to isolate them. We want them to be alone. Therefore, I will rewrite it again so you can visualize it more. So r squared cosine squared theta plus r squared sine squared theta minus 6r sine theta. And because the 9 is cancelled, all of this is equal to 0. So I think it is obvious that we should move the 6r sine theta to the other side. Therefore, we'll have this r squared cosine squared theta plus r squared sine squared theta. And the final or almost final step is just getting away the r squared. We will just kind of isolate it. We will factor it out. So r squared, and then we have this amazing identity. I think I should make a video where I prove this identity in multiple ways. And then this is equal to 6r sine theta. Of course, the result of this identity is 1. Therefore, we can write the final expression. R squared is equal to 6r sine theta, and we can divide by one of the r's. So I will divide here by r, and then here by r, Therefore, I will have r is equal to 6 sine theta. And this is our final answer. So this was it for the revision of the unit that is talking about the polar form. Again, if you have any questions, please feel free to reach out. Thank you very much.